So let us start. So do you have any questions from the previous class? So theorems on Laplace transform. Now actually, so by this time you might be known already finding out the Laplace transform for any random function, right? Now there are certain theorems that are related to it. Suppose if you know the Laplace transform of any random function f of t, then if you want to find out the Laplace transform of this is f of s, let us say, then what is the Laplace transform of t into f of t? So the function is getting multiplied with t. Now to know the Laplace transform of the function which is getting multiplied with t, and this is nothing but minus 1 into d by ds of Laplace transform. So this is the Laplace transform of the function if it is getting multiplied with t, multiplication with t. Now I'll give you 2 minutes time. Can you prove this from the base principle of finding out the Laplace transform? Can you prove this is equal to t into f of t Laplace transform is equal to minus 1 into d by ds of f of s? I'll give you 2 minutes time. After that, I'm going to solve it for you anyway. Okay, so let me prove this. See this. You know the Laplace transform of f of t is nothing but f of s. Now, the way we look at it is, this is f of s is equal to integral 0 to infinity e power minus st into f of t into dt. Now, if you take the derivative of this function with respect to s, then d by ds of f of s is given as integral 0 to infinity dou by dou s of e power minus st into f of t dt. Now, being this is the function of s alone, so this is anyway treated as constant because you are doing the derivative with respect to s, right? Now here, this is equal to derivative with respect to s is nothing but minus t into e power minus st into f of t dt, integral 0 to infinite, or this is otherwise minus 1 into integral 0 to infinity into e power minus st into t into f of t dt. So this is nothing but the Laplace transform of, so this minus if you take it to the other side, minus d by ds of f of s is equal to Laplace transform of t into f of t. Got it? Now the same thing you can even extend. Suppose if you multiply with one more t, that is nothing but t. So Laplace transform of t power n into f of t is nothing but minus 1 whole power n into d by ds power n of f of s. This is a generic formula. If you multiply with t, then the Laplace transform is getting changed in this format. Clear? Got it? Any questions on this? Done? So this is multiplying with t. You know the Laplace transform of f of t is equal to f of s. Then what is the Laplace transform of f dash of t? Can you tell me what is the Laplace transform of f dash of t? Anybody got the answer? Yes or no? Is the Laplace transform of f dash of t, if you know the Laplace transform of f of t. So this you can find it out, integral 0 to infinity e power minus st into f dash of t into dt. This is apply uv formula on this. Now this is the derivative is taken here. So this is f dash of t into dt is equal to dv. Integrate on either side, f of t is equal to v and u is equal to e power minus st. So that is f of t into e power minus st minus integral v du. So v is f of t into du is du by dt equal to minus s into e power minus st. This is minus s into e power minus st dt. Now this is nothing but the upper limit is infinite and lower limit is 0. Then so upper limit, if you substitute t is equal to infinite, this will be 0 and this is minus f of 0. Minus into minus is plus s into integral 0 to infinity e power minus st into f of t dt. So this is nothing but Laplace transform of f of t, or this is the Laplace transform of f dash of t is equal to, if you write this on to the first time, so this is s into f of s minus f of 0. This is the Laplace transform of the derivative of any function. Got it? So minus f of 0, it's not f of 0. Exactly in the similar manner, if you apply for the nth derivative, so the Laplace transform of nth derivative of t is nothing but s power n into f of s minus s power n minus into f of 0 minus s power n minus 2 into f dash of 0 plus or minus s power n minus 3 into f double dash of 0 plus dash dash dash. So finally n minus 1 the derivative of 0. So this is how you are going to get it. Got it? This is very important to understand because this is what we are going to use in converting a differential equation into the polynomial equation. So this is, look at this, we are taking the derivative of the function. So derivative is nothing but dy by dt. So dy by dt is converted into s into f of s, and this is anyway a constant. So if this is a constant, one derivative is nothing but getting multiplying with s. Two derivatives or n derivatives is nothing but getting multiplied this function with f of s, right? So this is f of s, it's completely a function of s. Then this is getting multiplied with s power n. So nth derivative is nothing but multiplication with the s power n. Integral is nothing but dividing with the s. So these values are the constants. So if you notice, if you put the constant values f of 0, f dash of 0, f double dash of 0 and all, then you are going to left with a polynomial. So this is the greatest and only advantage of Laplace transform, which converts a differential coefficient into a polynomial coefficient. That's it. Got it? Any questions on this? This you can prove it exactly in the similar manner. Use by parts and then you can prove it. Or else actually there is a chain rule, that is integral u dv is equal to u into v minus u dash v1 plus u double dash v2 minus u triple dash v3 plus dash 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 up to infinity. So this is your chain rule. For nth derivative, you can apply this principle, so that actually this chain will continue till the end where the derivative vanishes. So there you can stop. U dash, U double dash, U triple dash are all the derivatives, and V1, V2, V3 are the continuous integrations. This is what we call as the chain rule, which will be a simplified form of the by parts principle. Right? Hope you people are aware of what is by parts. So by parts, actually yesterday I have explained the UV formula. So integral u dv is equal to uv minus integral v du. This is called by parts. Clear? Any questions on this? Any questions on this? So you can note down this. Understood? Or do you have any questions on this? So if you notice, all these are negative signs. I hope everybody is aware of it. All are negative signs. So only the first thing is the positive sign. If you apply this chain rule, you are going to left with. Then, you know the Laplace transform of f of t. Laplace transform of f of t is equal to f of s. Then what is the Laplace transform of integral 0 to t f of t dt? F of u du. For this, actually, you need to find out the Laplace transform infinity. Somebody tell me what is the Laplace transform of integral 0 to t f of u du? What is your confusion, Hitesh? Rest all small f. What do you mean by that? Yeah, exactly. So the first one is capital F of s. Rest of the things are f of 0, f dash of 0, f double dash of 0, like that. The s power n is going to be reduced, but the derivative of f is going to be increased and substituted with 0. That is normal plain f of t function. So this is 1 by s f of s. Can you prove this? Imran? Yeah. So here, if you want to find out the Laplace transform of this, then let us say I call this as Laplace transform of function phi of t, where phi of t is equal to integral 0 to t f of u du. Now here f of u du, not it's a function of t. So it will be a function of t provided if you find the integral and substitute it. Now here in this case, phi dash of t is equal to f of t, but phi of 0 is equal to 0. So why? Because see this, phi of 0 is nothing but integral 0 to 0 f of u du. Now as long as the limits are same, the integral value will always come out to be 0, whatever may be the function inside in the integral. Right? So that's why phi of 0 is equal to 0. Now, if you want to find out the Laplace transform of phi dash of t is equal to Laplace transform of phi dash of t is nothing but s into phi of s minus phi of 0. So this phi of 0 value is coming out to be 0. Now, the Laplace transform of phi dash of t, right? So this is nothing but s into phi of s, and this is Laplace transform of phi dash of t. So it implies this is phi of s is equal to 1 by s times of Laplace transform of phi dash of t. Got it? Understood or not? So this is phi of s is equal to 1 by s times of Laplace transform of phi dash of t. Note it down. Any questions on this? So this actually, if you want, you can put it in this format also. Phi of s is equal to 1 by s times of, this is the f of s. This way, phi of s is equal to 1 by s times of f of s. Now, phi of s is nothing but, this is the Laplace transform of integral 0 to t f of u du. This is phi of s. So this is equal to 1 by s times of f of s. This is finding out the Laplace transform for an integral function. Got it? Note down one more. Division by t. Now, if the Laplace transform of f of t is equal to f of s, then what is the Laplace transform of f of t by t? Can you try to solve this? So what is the answer for it? To integration limits. What are the limits of integration? This is an intelligent guess only. So you know the Laplace transform of f of t is nothing but f of s, or this is nothing but f of s is equal to integral 0 to infinity e power minus st f of t dt. So this is the Laplace transform of the function f of t. Now, if you take the integration on either sides from s to infinite, this is just a guess. So if you make the integration from s to infinite, you are going to do the derivative with respect to t, or sorry, integration with respect to t, with respect to s. So t will come at the denominator, which we are going to see it now. So this is s to infinite, this is ds. Got it? Now, this is left side, you can keep it as it is, but from the right side, by changing the order of integration, now what you can do is integral 0 to infinite, integral s to infinite e power minus st f of t into dt into ds. Now in this integral 0 to infinite, integral s to infinite e power minus st into ds into f of t into dt. This is how you can put it. So being these are the s limits. Got it? Now here e power minus st into integration e power minus st with respect to s. This integration will be integral 0 to infinite, this integral e power minus st divided by minus t. Upper limit will be infinite and lower limit will be s. So f of t dt. Got it? I hope everybody understood this concept. I have just done the integration on either sides with the same limits with respect to the same variable. Then I change the order of integration. So the order of integration is changed to with respect to s first and then with respect to t next. So when you do the integration with respect to s, t will be treated as a constant. So here minus t into s is the integral value. Here we need to be finding it out. E power minus est. Now if you do the integration, this will be e power minus st by minus t. Upper limit will be infinite and lower limit will be s. Now upper limit, if you substitute it, this value will be 0, and the lower limit, if you substitute it, it will be e power minus st by t. So this is equal to integral 0 to infinite e power minus st f of t divided by t into dt. Now this is nothing but the Laplace transform of f of t by t, and which is given as this one. Got it? Understood? So these are the four theorems, that is multiplying with t power n, which will make the f of s value minus 1 whole power n times of nth derivative with respect to s for the f of s. That is multiplication with t power n. Now division with t is nothing but changing the integral value, that is f of s, you need to integrate from s to infinite. So this is nothing but, if you divide with t for the function f of t, you are going to get the Laplace transform of f of t by t if you integrate s to infinite f of s. This is division with t. And another is the derivative of the function. So if you take the derivative of the function, then it will be s times of f of s minus f of 0. If you take the second derivative of it, s square times of f of s minus s into f of 0 minus s, so s power 0 into f dash of s, f dash of 0. That is the second derivative. Similarly, the integral value for the function, if you want to find it out, the Laplace transform of integral 0 to t f of u du is nothing but 1 by s times of the Laplace transform of f of t. So that is division with t. Got it? Any questions on this? These are the four basic principles which we will be using in case of finding out the Laplace transforms for different kinds of functions. So based on this understanding, we'll solve some of the problems based on this. In the next class, I'm going to deal with how to find out the inverse Laplace transform. Find the Laplace transform of t cos at. Somebody tell me what is the Laplace transform of t cos at? Also t square sin at. That's correct. S square minus a square divided by s square plus a square into whole square. What is the Laplace transform of t square sin at? Double differentiate and tell me the answer. For sin at, you need to do the double differentiation. This is one of the easiest topic, but most of the people might have already studied in engineering also. What is the Laplace transform of t into e power minus t into sin at? Sin 3t. What is the Laplace transform of it? This answer is 3. 2a into 3s square minus a square divided by s square plus a square whole cube. This is the answer. Find the Laplace transform of the last one, t into e power minus t into sin 3t. Yeah, that's correct. Laplace transform of t into e power minus t into sin 3t. We have to use the first shifting property for this. The answer is 6 times s plus 1. I think it's wrong answer. What do you have here? 6 times s plus 1 divided by s square plus 2s plus 10 whole square. This is the answer. So use the first shifting property. Laplace transform of sin 3t is a by s square plus 3 square. Now if you use this is Laplace transform of sin 3t. Similarly, Laplace transform of sin 3t into e power minus t is nothing but 3 by s plus 1 whole square plus 3 square. So this is the Laplace transform after multiplying with e power minus t. Now if you want to find out the Laplace transform of t into e power minus t into sin 3t is nothing but minus times d by ds of this above function. That is the order we have to do. What is the Laplace transform of 1 minus e power t by t? What is the Laplace transform of e power 1 minus e power t by t? Log s minus 1 divided by s. Yes, that's correct. Anybody else? Got it? So this is straightforward only. The Laplace transform of 1 minus e power t is nothing but 1 by s minus 1 by s plus 1. S minus 1. Then this is Laplace transform of 1 minus e power t by t. This value you can find it out by integrating from s to infinite 1 by s minus 1 by s minus 1 ds. This is log of s minus log s minus 1. This is log s by s minus 1. Upper limit is infinite, lower limit is s. So upper limit, if you want to substitute infinite by infinite format, that's why what you can do is you can divide with s from the numerator and denominator so that you can make this equation simpler. 1 by 1 minus 1 by s. So the upper limit is infinite, lower limit is s. So when you substitute the upper limit infinite, this will be 1 by infinite is 0. Then this will be log 1. Log 1 is again 0. So 0 minus log of upper, so lower limit if you substitute it, it will be as it is, that is s by s minus 1. So, but this is minus of, then what you can do is, this is log of s minus 1 by s. This is the Laplace transform after dividing with t. Understood? Or do you have any questions on this? You know the Laplace transform of f of t. What is the Laplace transform of f of at? Know the Laplace transform of f of t. This is f of a, so f of s. Then what is the Laplace transform of f of at? So f of at, if you want to find it out, integral 0 to infinite e power minus st into f of at dt. Now to solve this integration, let z is equal to at. Then dz is equal to a times of dt or dt equal to dz by a. Now if you replace it here, similarly, so t also you can express in terms of z as z by a. This is integral 0 to infinite. So lower limit when t is equal to 0, z will also be 0. When t equal to infinite, z will also be infinite. This is e power minus s into z by a into f of z into dz by a. This is 1 by a times of integral 0 to infinite e power minus s by a times z into f of z dz. So this is nothing but Laplace transform of f of z, but treating instead of s it should be s by a. So this is as if like 1 by a times of f of s by a. So this is also called as change of scale property. Change of scale property. Right? This is also called as second shifting property. So first shifting property, that is multiplication with e power t at, that will change the equation to 1 by s minus a. Similarly, the second shifting property is nothing but scaling property. So t is getting multiplied with a, so that means it is scaled to a times. So then the Laplace transform is going to be 1 by a times of f of s by a. So s has to be replaced with s by a, and entire f of s needs to be multiplied with 1 by s. So 1 by a. Right? Change of scale property. What is the Laplace transform of find the Laplace transform of e power minus t integral 0 to t sin t by t. Find the Laplace transform of it. Cot inverse. So the answer is 1 by s plus 1 times of cot inverse of s plus 1. Yeah, that's correct. See this, we'll take this. Laplace transform of sin t, nothing but 1 by s square plus 1, because a is equal to 1. A by s square plus a square, where a is 1. Then the Laplace transform of sin t by t, this is dividing with t, will be equal to integral s to infinite ds by s square plus 1. So this is tan inverse of s. Upper limit is infinite and lower limit is s. This is pi by 2 minus tan inverse of s. Got it? So pi by 2 minus tan inverse of s can be written as cot inverse of s. Now this is the Laplace transform of sin t by t. But you want the Laplace transform of integral 0 to t sin t by t. Here, the Laplace transform of the integral is nothing but divide with s. So 1 by s times of cot inverse of s. This is the Laplace transform. Now, finally, there is e power minus t multiplication. That is Laplace transform of e power minus t into integral 0 to t sin t by t into dt is equal to, so this is apply the shifting property. So s becomes s plus 1, 1 by s plus 1, cot inverse of s plus 1. Got it, Samlin? Got it or not? So I hope everybody got the same answer. So this is the way you should be finding out the Laplace transform of any random function you can think of. Okay? So with this, actually I'd like to conclude today's class. So if you have any questions, you can let me know. Got it? Any questions? So tomorrow I am going to deal with the inverse Laplace transform and the convolution theorem. So after that, there will be only one class that will be left over, that is finding out the solution of the differential equations with the help of Laplace transforms. With that, we will conclude this ODE section completely, including Laplace transforms. Clear? Got it? Okay. Yeah. Thank you.